Example 6. So here's some more strategies with the update. So we have start with the most complicated side. Now here it says this reciprocal and quotient, that would be changing the sines and cosines. They combine it with Pythagorean. Factoring is the algebra, and then we had conjugates. Now the other one we've discovered is you can work each other side separately and see if you can solve from there. This right here is the reciprocal and quotient. So there's some strategies for you in typed up form. Now it says use a graphic calculator to test whether these are an identity. So what we're going to do here is we're going to graph each side. We're going to see if these equals one another. So I'm going to type this in as f1 of x and this as f2 of x, and I'm going to ignore the equal sign. So that's what I'm going to do here. So I'm going to break it at the equal sign and graph them. Let me get a little dotted line, separate it here. So that's what I'm going to do. I'm going to separate these two sides. So let's go over to their calculator and type these in. The first equation was that we had a fraction of 1 plus tangent squared. And so you go to trig, tangent, x. Now what's weird in our calculator is we have to go outside the parentheses right there and square it from that spot. That's where we'll do the squared. It will not work on this location in our calculators. And that's over CSC cosecant of x times the trig function secant x. And we want to see if this is congruent to the trig function tangent x. And enter, you see that they are. So we did verify that these are the same graphs. So I go over here and I'll just take a picture real quick. So now if you look at the picture, we can see that it is verified and it's true that these two are equal to each other. So if you want to go through the algebra of verifying it, what you would do is you would take up the more complex side, which means it would be the left, and work from here. I would start with 1 plus tangent squared. If I look at 1 plus tangent squared, that's equal to secant squared. And so I'm going to change the top using Pythagorean theorem. Whoops, AG, Pythag. And I would have that secant squared x over CSC x times secant x. And now I would simplify by saying this one of these secants cancels with this one. And so I have secant over cosecant. Now I'm going to help myself out by doing the reciprocal. But I'm going to do it twice. I'm going to move secant down, and I'm going to move cosecant up. So the reciprocal of secant, when secant's in the numerator, is cosine in the denominator. So this becomes a new denominator of having a cosine. And cosecant in the denominator, if you look over here, cosecant in the denominator is the same thing as sine in the numerator. That's its reciprocal. So when it flips up, it becomes sine x. Well, this, according to the quotient identity, sorry, I meant to change colors. Let's try that again. The quotient identity says that we have sine divided by cosine. That is y over x. Psi y cos x. Tangent is y over x. Is that what we sought out to establish? Yes, it is. So this would be my correct answer here. So I proved it. Let's take a look at another one. So here's just pictures that they provided. Now let's use a graphic calculator to determine these. So I'll go back to my graphing calculator and clear this and graph them. I'm going to just pause the video for a second. Okay, so now I've graphed these. Now remember what we do is we come over here and we would divide this right here at this spot. Divide it right here, and I'm going to type this side in as F1, this side as F2. And so I've graphed, and here's the left side, that's my F1. And so when I press tab here, I'm going to look at my other equation as F2, and I'm just going to hit it like this, and now I graph it. Are those two the same graphs? No, they aren't. So this is not equal to one another, and so I just have to pick an x value where they are different. So it says find an x value by which both sides are defined but not equal. So I would just say, what about when x equals 1? They are not the same. So if I hit Control T, I get a tab, and you see the x values at x equals 1. The sides are defined but not the same. Both sides are defined. That means they have real, like, number values, are defined but not equal. And that would be my answer, and I should probably put a comma there. So that would be what the graphs look like. And so here's a picture, and they just showed on theirs. And it looks like I might have typed something in wrong. So let's go back to my graph, because if I typed something in wrong, that wouldn't be the right picture to begin with. So let's come over here. Okay, Control T just for a second. Or maybe if I maximize this out. Nope, that won't work. So I found my error. I had sine squared, and you can see it. So now when I hit enter, it should change my graph. And so either way now, we're looking, it's still incorrect. And at 1, they are different values. So it is in fact incorrect. So now you have this one to try.